All right, perfect. Thank you for joining us. I know it's the more advanced stage of ECC. I'm sure everyone's feeling the burn, but I think it's important for us to decipher the subject here. I am going to say that I am a marketer by trade, so I'm not a ZK researcher, not a PhD. I've been doing this space for long enough, but we're also going to try and keep the discussion, I'm not saying non-technical, but also, I would say, accessible. So first of all, really briefly, if everyone could just introduce themselves and how they got to sitting on at the Warwick, Brussels, talking about ZKs, and how'd you got here? Please.
Hey guys, my name is Rami Khalil. I'm a senior protocol engineer at Risc Zero, and it's been a long journey. I think I've been in blockchain since 2018, and mostly academic from 2018 until 2022. Masters and PhD, mostly focused on blockchain. Yeah, it's been quite a long journey. Officially got into ZK since 2 years ago, I'd say, with Risc Zero. And yeah, just the willingness to can constantly learn new things, I'd say, is probably going.
Hello, I'm Neville. I'm a co-founder and security researcher at Dedaub. We're a security company. Before co-founding Dedaub, I was mostly an academic researcher, so a PhD in program analysis and computer science. And I've been doing a lot of research, trying to apply these techniques to security over the years. And yeah, that's where Dedaub came about. So Dedaub is a security provider providing decompilation services. We do monitoring, we do static analysis and some formal verification, and we also do a lot of audits, especially with larger protocols that are more complicated and require high expertise.
Hi, this is Ming Guo, the chief scientist of ZKM. So yeah, I'm your host. Welcome to our party. This is the second half of ZK, and it's packed. I really like that. All right, let me go backwards. So here at ZKM, it's actually from ZK MIPS. So we do zero-knowledge proof virtual machine based off the MIPS architecture. I really like MIPS. You'll see why. All right, so the ZKM project is a spin-off of Metis, which is a layer 2 solution for Ethereum, mostly optimistic rollup, but with ZK MIPS will be aggregated to hybrid rollup. I may have a chance to explain that later. And prior to that, I'm also like a 2017-18. That's the time I entered the crypto space with a project I also dwelled on what was popular around then, confidential transactions and kind of like a Zcash, Monero. Yeah. Prior to that, I was just a hardware software engineer in Silicon Valley for a long time, all the way back to when I worked alongside the people who created MIPS. Yes, I was at Cray Supercomputers acquired by Sync Graphics. I was in Building 8, now Google. So yeah, so it's full cycle from MIPS to ZK MIPS.
Perfect, thank you very much.
All right.
Hi, I'm Sarah. I'm temporarily replacing Vince for now. Yeah, so I'm from the product team here. And essentially what we are working on is that we are actually building a zkLink Nova. So it is an EVM compatible on network, which aggregates a set from all the different L2 rollups and also Ethereum itself. So the ultimate end game for us is to solve the liquidity fragmentation problem in the space, and essentially we are stack agnostic. Yeah.
All right, perfect. I'm going to start with a question. I'm sure that each one maybe has his position because that's where they decided to develop their technology. But I think everyone here understands the importance of ZK, and I think it's already understood as one of the leading paradigms in the space. The question is, at what layer, what stage do I need the ZK? Is this a layer 1? This has to be the definition of what we're doing and everything that you're doing. Is this more, as we said, more of a layer 2 when you touch this scalability part, or is this actually a layer 3 component only on the app, on the actual and transaction or whatever. So at what point, if a builder is now looking to build a project, should he try and find the right place where ZK is supposed to, I would say, sit?
Well, I would say that the best place to use ZK technology is either an application running on an L1 or an application running on an L2 which doesn't use ZKP technology, or for implementing L2s. And the reason for not having ZKP technology on L1s is because ultimately you're going to have to run this on a regular machine, von Neumann architecture, whether it's MIPS, CISC, or Risc. And
every time someone says MIPS, you have to take a shot.
So yeah, that's the reason. So normal architectures are much more suited to running L1s at scale at this point. So that's my opinion.
All right.
I think the best technology is the technology that's hidden, right? It's not just hidden from the users. Better is hidden from developers. So that's our goal here. Let me borrow a page from my good friend, the Zero. They had a slogan that I really like because we're similar in that way, is that build programs, not circuits. So right now, you probably need a good cryptographer in your team. You have to know, intricacies of zero knowledge, which is really hard. I bet many students kind of just slap off the first lessons of computation, theory of computation, right? So yeah, it's easier just to learn JavaScript. I want it that way because with the JavaScript script, for Solidity programs, you have millions. You can build millions of the apps. You can touch all aspects of application. So that's good. You don't need them to learn ZK. So I think it's not just layer 1 or layer 2. It should be like the lowest part, like the instruction part. That's where we build ZK MIPS and other ZK VMs. So developers, you don't need to care. You just get your binary. There's nothing of ZK you need to touch, but then you benefit from ZK from the ground level up.
Right. Thoughts?
I'd like to add to that as well. ZK is a pretty big stack to adopt, honestly. Like, in the context of blockchain, it's pretty useful because verifying is much cheaper than proving, and then if you publish this on a distributed network, you release the work that the verifiers have to do, and then your application might be more cost effective, but you're also depending on something that might be a bit hard to understand at first. So I think I'd give the generic answer of, adopt ZK only if you really have to. Don't, have a fear of missing out or anything. But if your application is, feasible to run fully on-chain, then you have to find some kind of solution, right? And ZK is a really natural solution in this context.
Sure. You want to add, or should I move on?
Yeah, so I think in my opinion is that ZK technology, it should be on the L2 or L3 layers. Essentially, because I think when you think about it, like you aggregate all the different rollups on the L3 front or even L2. So essentially, some of the application, right? They would definitely need like the ZK technology. Like one use case I can think of is in the poly market sector. So essentially, when people are placing like their bets, or that sometimes they want to hide their on-chain transactions, or that could be hidden from the application layer. But the application, they don't have to do that. They can utilize on the stack itself or the L2 or L3 chains. And then on the other hand, for those non-privacy critical application, for instance, like on the social media side, where they need to track like the end-to-end user behavior or those kind of information, definitely the L2 should be helping out with not automatically implementing that ZK proof for them. Yeah.
Perfect. So I want to actually touch on something that you said and ask the crowd. The speakers. Are there certain use cases that ZK isn't the best setup for? And again, I also want that for builders to take out. Is there certain types of apps or applications that maybe people should just look at different paradigms? It could be Plasma, it could be FHE, people talking about zero proof. What's not good for ZK?
I have a really jaded, biased answer to that. Not politically correct. It's zkML. Because you don't want overhead. Like AI already has a big overhead. ZK has overhead to the 6th order, but it could be reduced with current technology to probably order 3, maybe half of that. And with hardware and everything, we probably could get to a usable case. But you actually don't want to do that with AI applications right now. But it's evolving. So I'm mostly from a practical point of view, it's too expensive, too time consuming. So you need to use it to secure your financial applications, I think, at the time.
Rita, I'm sorry, go ahead.
So I completely agree with you.
Double shots fired.
Yes.
I love it.
That's good.
Yeah.
So we've over the last 60 years, a lot of the algorithms, including algorithms used in ML, have been highly optimized to run on machines that work using bits and represent numbers between 0 to 2 to the n minus 1. And it's very, very efficient to do things like XORs and things like that on regular machines. Whereas on ZKP systems, say for instance Groth16 or Plonk or anything else probably, it's way easier to do a square root on a prime field, for instance, which would be on a typical application much harder to do. And so because of that, even there's various kinds of cryptography that don't work that well on ZKP systems, ML, and any other kind of high-performance computing is not a good application.
I mean, I don't think inference is completely insane to put in a ZK context, because inference is much cheaper than training. Like, if you want to put the entire ML stack in ZK, then yeah, you have some problems, because maybe you want to train on some private data set and then just have people locally train these models and then give you like a provably derived model. But yeah, that's hard to pull off. But if you have a model and you want to run this on a piece of data, not all algorithms are completely infeasible to do in ZK. Some of them are somewhat okay, acceptable, especially if the use case is sensitive enough. So.
All right. Do you want to end or do you want to move forward? I move? All right, cool. So the panel is about interoperability. So I do want to ask about this. And again, this is my non-technical side, and I've been in crypto for 10 years, etc. I know ZK is like this EVM thing, and that's for Ethereum, and it's like, and keeping things safe and on the application layer, L2 layer. When we talk about interoperability, how does ZK take in place? Can it replace other paradigms? Is that like, okay, we're going to try and not do the SDK model of the Cosmos, we're not going to do that. Like, how does ZK play an important role when we want to start doing interoperability? Does it make things harder, or does it actually solve that problem?
Let me drop a bomb. This is a real bomb.
Are you ready?
People are kind of still at the gate of the possibilities and the power of the zkVM. Because zkVM can prove computation trace, which is any computation, not just any program, but any computation. And that power is really powerful. It can just bomb everything. The old ways of doing interoperability, we can solve all our problems, even to the point that they've never achieved. And we can even redesign.
Do the other chains have to accept EVM superiority and build themselves in a certain way, or?
Well, my answer is no, because we're a zkVM, we're not zkEVM. Some people say, yeah, it's better just everyone adopts it, but no, not necessarily. You don't even need to change your implementation of your layer 1, layer 2, or layer 3, because you can just offload all that computation off-chain. So you can even prove like a C++ program from 20 years ago, and you say, this is important, I need this to function. You can do that, and you can crop that. You can have that interoperability. You can have that information, across chains.
Okay, thoughts?
Yeah, ZK is pretty good for interop in the sense that if you want two chains to have an understanding of or be able to pass messages between each other. They don't necessarily need to understand how to validate each other's proofs. If they're using the same proving system, you just need that same verifier to run on both chains, and then you can abstract away the logic of each chain from the other. So there are some really exciting developments.
And for the maybe not super technical or whatever, why is that a better solution than, let's say, a layer 0, a chain link, a XLR? So why is messaging per se not as good as doing it via ZK? What?
Rug pulls, I guess. That's one main reason. I mean, we've seen.
Explain that. What do you mean, rug? Like.
Sure. So, for instance, we've seen. I mean, one example of a bridge where a lot of the currency was stolen. I think at least 2 or 3. Like there are some unknown ones as well. And using ZKP verification technology, especially if you're using the same L1 because it's easier. You can.
Yeah, but then it's not that interoperable. We're talking about interoperability as in, I know it's hard to say that at ECC, but there's a thing called Solana, there's a thing called Move. There are other blockchains, and some of them do have some people doing some stuff on it.
You can also mention Bitcoin, that's okay.
Yeah, Bitcoin, that's true. We forgot about that. So, yes, in an EVM world, I understand that, but in a world where we want to start bridging everyone together, how is ZK gonna?
Honestly, I know this is an ETH conference, but Bitcoin is like the best example, because if you look at the developers of Bitcoin, they've always been very hesitant to expand the programmability of Bitcoin. But if you have only this ZK verifier component, then you essentially don't have to worry about that anymore. You can only support that efficiently and securely, and then you let the developers do what they want.
I also might add a keyword is native assets. Traditional bridges don't have native assets. It's just another address from another guy or another group of hackers that you don't know, or criminals. So ZKP, especially ZKVM, can provide a kind of proof of consensus. So you have native assets cross-chain. This has never been done before. The rug pull, you can never rug pull against like they're not proof because you have self-custody.
Well, if you're thinking of developing an application on a zero knowledge enabled chain, for instance, you gotta check how different the semantics of the EVM is from one chain to the next. So the same application cannot really run across chains. You kind of like need to change it a little bit. This is especially prevalent, for instance, in ZK Sync era, for instance, right now. So the second point is if you're building a new ZKP technology, there's a lot of, the problem is that it does require a lot of work. Implementation of new cryptography.
Actually, I'm less about infra, and I want to touch that later. I know that we're all about infra. At some point, we need applications. I hope, like as a marketer, I hope someone will build some applications. So I'm talking about people now will use all these ZK stacks. They might not be as technical. They don't have all these PhDs. There's this huge promise again as a not super technical person that, as you said, it'll change the world. It's proven. It's graded. No one can touch it. How far is that from the actual truth, and how much has it been actually graded and tested, and how much can any builder just go and enjoy, as you said, the ZK on the base layer and never even have to think about it? And how much are we going to see those types of data leaks or rug pulls or whatever? Because when you say rug pulls, it's just a lot of people have done certain things on crypto, and people have done malicious actions and found how to hack it. If a lot of people, a lot of applications are going to start using all these ZK L3s, a lot more people are going to find different honeypots, and we might see testing in a different manner.
Yeah, there was a thing on Twitter about that today, right, where someone was saying that, oh, you don't automatically get privacy because you're on some kind of ZK-powered layer 2, and that's true. Like, ZK is a primitive. You have to understand exactly what the guarantees you're getting are, and just because you are working with something that is powered by ZK, you don't automatically get, full privacy, full security. Your application might be programmed to leak some information on its own. And even, this is kind of a hot take, but a lot of the current ZK solutions are not ZK in the sense that they have cryptographic privacy guarantees. They only have verifiable compute. So that's always also something to maybe take into consideration. It also hasn't been really fully explored or, well, abused significantly yet to trigger people to look closely at it.
Yeah, I think there's a misunderstanding of the zero knowledge part. It's actually not really zero knowledge that's important. It's actually should be calling a succinct proof of knowledge. But zero knowledge is kind of cool. But you can achieve some kind of privacy because you have when you do a zero knowledge proof or like validity proof, the constraints and the inputs are the ones that you control. That if you make the input kind of confidential, then you can have some kind of zero knowledgeness of it. So this is actually pretty important. For banks, for commercials, in blockchain, everything's transparent in the first place. So zero knowledge is not as important. It's mostly like succinctness that's important. So that's the part that's kind of misleading. It's the misnomer. So I think it's better not call them the zero knowledge proof. Like the better term is like validity proof.
Well,
I had a dad joke all week that I've never met so many people so proud that have zero knowledge. But anything to add, or should we kind of move on? Yeah. All right. Cool. Let's move on. Let's talk about liquidity and fragmentation. I think that's a very big part of that. We have a bunch of chains, L2s. I think I seen some report that there's been more than 95 L2s that have crossed the $2 million in funding by anyone or whatever. So we're at there's L2s as a service. How do we make sure that the people that will build applications, hopefully one day on all these infrastructures, enjoy a situation where their users don't have so many issues with liquidity and fragmentation? Please, I'd love for you to start. Yeah.
Can you repeat your question again?
Yeah, liquidity and fragmentation. How do we kind of deal with that specifically with all these L2s and all these ZKs? How do we combine all that in a situation where users, in the end of the day, will be able to be in a situation where they enjoy liquidity and they don't have to have every chain have all the liquidity in the world?
I think essentially it boils down to one word, which is abstraction. Users do not need to, pick like what chain they are on. So essentially at an infra level, definitely someone has to come in and try to unify or aggregate all these different L2 rollups chains together, so that essentially all the different fragmented liquidity from the L2 rollups and Ethereum, and essentially from the L1s as well, it's gonna be it's gonna be aggregated onto like a single layer. Yeah.
Thoughts? How do we make this something that works in the end for users?
Right. I think Ethereum it's natural, right? It's very easy to get aggregated single liquidity, but across if you do cross chain, right? Like we do cross chain, we call cross chain rollup. My colleague will give a presentation later. Integral, which is a cross chain rollup. Liquidity is naturally fragmented because cross chain is always hard. So zero knowledge proof merge machine can provide a technology base that can mimic what we have in the world's banking system, right? That you have who's providing liquidity in the banking system. The banks, a lot of the time, a different level of banks. You have central banks, you have commercial banks. All of them can provide some kind of liquidity. Like in the real world, individuals can provide the liquidity too. Like example, also in the blockchain world, I think Bitcoin has a light network. It's going to rely on individuals to provide liquidity in a limited way, but they aggregate them. But it's still limiting because your transaction can be limited. The one who provide the most liquidity, if someone can only guarantees 10 Bitcoin, so you cannot transfer anything to any business transaction more than 10 Bitcoins. And most these days, because Bitcoin is so expensive, probably very small. So that's why light network is a problem. But I think with cross-chain rollups, with zero knowledge proof, you can kind of carry that request as some kind of a check. So you can imagine zero knowledge proof, actually a more complicated one, like what we do, zero ZKVM proof of state transition, transaction. as like a check, and you can take that check to a liquidity provider, which is a contract. In our protocol, we call them shadow contracts, and those are like banks. Now, for example, you can have individuals with the liquidity you want, whatever, like Bitcoins, Solana, whatever, and they can have just a lot of like these shadow contract operators just provide liquidity. You can also have the big ones, right? Like USDT, they can have their master shadow contract provider, and that's kind of unlimited. They're kind of like the central banks, like so. We mimic with this technology. We can mimic like the financial system of the world to provide liquidity.
Very interesting.
Yeah, which is naturally fragmented, actually. That's, when you do cross-chain stuff, you have to accept that you can only achieve economic security. If you want all these systems to work together in lockstep, then you're essentially combining them into one system again. So it's sort of a circular reasoning.
I tend to agree with you because I think fragmentation has to do with just human, activity. There's a bunch of fiats in the world, and at the end of the day, more people buy dollar for whatever reasons, and that's because of human nature. And of course, we have the different SWIFT networks, whatever, but we can't deal with the fragmentation of the fact that people just rather have dollars in their pocket than other currencies. So it's not maybe an infra problem; it's a human problem. That's what people do.
Yeah, you just need it when you need it. You don't need like a big pool of like just sitting there, right? Somebody to control all the supply, money supply. That's what I had.
Perfect. So I want to use the last few minutes for I think more like wider questions for me as someone who's I think finishing up, or maybe you guys have more time here, but we've been here for a week. Hundreds of side events. Really, I think one of the biggest crypto conferences, especially in the past few years. But as someone who's more on, I would say, the non-infra side, I have to ask all the infra people. Do you really think what we're missing is more infrastructure in this space? Like, I feel like there's been more side events than applications on the blockchain. So, and as sitting here in a bunch of panels, not you guys saying, oh, we have a marketing problem or whatever, I'm actually thinking we might have too much infrastructure, not enough applications. And how do we as an industry, I know that's not on the books, I wasn't ready, but that's a question that's yelling to me from this conference. Is there such thing as too much infra?
Well, it's a good question. I think what we need is more applications which have a product market fit and that they can actually solve problems for end users. Now, there's a lot of infra, but a lot of infra is also kind of like in development, right? But I think maybe in like a couple of years, we will reach that conclusion that there were too many chains being developed that were doing similar things. And at the end of the day, there's not enough demand for transactions, like transactions per second, for all this infra. Like you can probably satisfy.
I can tell you as a PR and as a marketer, when our clients come to us and talk about their TPS, I said, well, the question is what's on the block? I don't care if your network goes to 11. If it's empty, then I don't want to pitch any of this because the problem is not how fast it goes, it's how empty it is.
Yeah, totally. I was just saying that too many projects of building shovels. We need people to be, to get the shovel to dig some gold. So where's the gold? So that's why we're kind of more focused on application, like roll-ups, because cross-chain roll-ups.
But I think you can really see this in the space right now, and it's actually taking liquidity from real things, because if in previous cycles we were talking at least about doing applications, even if they ended up being small cap or rug pulls, whatever, there was that dream. The retail have now cut that out and they're just doing meme coins because they've already seen the promise of applications. It's all good, it's all good. I feel like they've seen the promise of applications as almost like a meme. So I know it's a nihilistic kind of thing of looking at it, but how do we get even the people inside crypto to even understand the people that you'd rather go and support and believe in this than a dog with a hat? It's a big question, I know, sorry guys, but like, how do we build better applications? How do we can the infrastructure already be built differently?
Build a better user experience or liquidity?
Founders, environment, thinking about applications from the. I'm just really, I know it's a hard question, I don't expect you to solve it right now, but I'll ask the smartest people in the room because I'm not. How do we make sure that in 2, 3, 4, 5 years from now, how can I, if I want to do not ETHCC, not an infra ETHCC, I want to do an app ETHCC. how do I make sure that 5, 10, 20, 30,000 people will come to that in a few years? What do you guys need from us, the non-researchers, to build?
I'm going to give you a terrible answer.
Sure, give me anything.
I think it sort of follows something similar to the induced demand model, where, for example, with cars, as you build bigger roads, you just get more cars because more people can then go down and drive their cars to where they need to. And I believe it's the same for decentralized compute. A lot of applications just aren't there because, hey, you have some infrastructure that has a certain level of bandwidth right now, but it's actually nowhere near enough to host some applications. Like, recall CryptoKitties, for example. I think that was the turning point where everyone realized, oh, we actually need a better way to scale. We haven't seen the CryptoKitties for L2s yet, for example, but it's sort of because people realized, hey, if I deploy another thing that will just take up all the bandwidth, it will just come crashing down and become unusable.
I'm sorry to depress everyone, but you just used CryptoKitties as the best example of applications on the blockchain, and unfortunately, that's the last time we clogged the blockchain.
Yeah. Well, that's, I guess, how much better we've gotten at, realizing that, hey, if this gets too big, it will clog the blockchain, and the current level of infrastructure is enough to, I guess, absorb everyone's current ambitions. I'm just saying, dream bigger, I guess.
Okay.
Clog it again, and then we have to go back and fix it.
Let's break it again and then fix it. So we'll need more infra.
Yeah.
Exactly. All right, perfect. Any other answers, or should we move on?
Yeah. Oh, okay, let me just pitch it.
Yeah.
Yeah, I think the past couple of years of Ethereum development is actually triggered by CryptoKitty kind of clogged the Ethereum system. So scalability, Ethereum's, I think it's kind of solved. We developed some really good solution to the trilemma, like data availability, roll-up, layer 2, right? And these technologies should spill to other blockchain systems. So that's why I'm very focused on cross-chain. And also, in terms of user experience, I really like to see some, like for example, social-fi, game-fi, non-financial decentralized application, because that's the future. But how the world works, you still have to solve the financial liquidity problem. So let me give a very kind of financial kind of point of view.
Yeah.
Like we have all this, we waited 10 years for this kind of all kinds of ETF to improve. Now suddenly, we have Bitcoin ETF, and then suddenly Ethereum ETFs are approved. But then if you just follow these, a lot of money come in and they just take a look and go. Why? Because we can't, blockchain as of now, they cannot provide the kind of user experience for traditional finance. User experience doesn't really mean UI, it's not software, it's the kind of system, right? So they come in, for example, you have a family office, right? $100 million, you're a couple generations wealth. Do you want to, have I want 10x, 100x, I want to invest in an order 10,000x. No, they don't want that because they can lose a couple generations of wealth just in 12 minutes. What they want is a sustainable yield of maybe just 1%, 12%. Now for blockchain, cryptos, even Bitcoin is very, volatile.
Yep.
So, but with what I said about cross-chain, with all this liquidity, you can build, applications to provide structured assets with different risk level. Then they'll come, they'll stay, the ETFs.
Right.
And then with all that, you probably can have an ecosystem to kind of fuel your social fi, GameFi. That's what I
All right. I hope as well. All right, perfect. We have a few more minutes. I'd love if everyone can kind of tell the audience if they're interested in what you guys are up to. Where should they go? Where should they check you guys out? What's the kind of main thing if they want to, have 5-10 minutes after this to spend a certain, feature or thing that you guys are really excited that you guys are up to, and then we'll let everyone. You guys are going to be around, so if you guys want, you can also, of course, talk to them.
Yep. Yeah. So if you guys want to check out more about zkLink, can go onto our website. And essentially, just to let you guys know as well, in terms of improving user experience-wise, in 2 to 3 months' time, we're gonna launch like an architecture that supports a more intent-based trading side of things. And also not just that, we are gonna work with either layer or AVS front just to reduce the time of withdrawal and see how we can improve on the optimistic rollout withdrawal time. Yeah.
Right, for me it's simple because you're here as our guest, ZKM, so just check out zkm.io and also talks by my colleagues, Pablo, Lucas, to give talks and other panels to understand our technology. So we're building ZK MIPS, it's a ZK VM as I mentioned, and also a cross-chain rollup called Entangle Rollup. Yeah, check us out and enjoy your drinks and food, have a good time. Thank you.